Thank you for coming out, everyone. I know this is a tough time slot. There's a lot of cool talks. So it's really cool to see a room full of people to watch us talk about this. So we're going to talk to you guys about this crazy thing we pulled off which doesn't have a name yet. It's Clojure Unity is what we've been calling it. We don't want to be sued by Clojure or Unity, so we tried very hard to think of a name. We were worried we'd be here and just call it Podium, or just like whatever it was in front of us. So we're just calling it Clojure Unity for now, but there's a name change impending. So I'm Ramsey Nasser. That's Tim's Gardner.
Hi.
These are our Twitter handles, and this is, we built this together. So just to sort of get a sense of the audience, how many people here are Clojure developers? There it is, okay. How many people here have developed a video game in their lifetime? Oh, wow, okay. How many people have developed a video game in a Lisp? Yeah, yes, I knew you guys would be here. Yes. Naughty Dog or some, oh, are there Lisps out there? There was like a moment in the 90s when Naughty Dog was using Lisp in video game development. So for the people who have done it, know this, and the people who haven't should. Game development is really, really hard. And it's hard for really specific reasons. And I want to talk to you guys a little bit about why Tim's and I even bothered to try something like this, and how we did it. So when you're making a game, you're managing huge amounts, really weird input. Like on an iOS device, you have like touches, so that's X and Y coordinates, and that's okay, you can reason about that. But if you have a Kinect, you're getting human skeletons that you need to like process and deal with, and that's completely bizarre. So there's no like spec that you can refer to, like, you know, if you're building a web server or something. There's no, your input is totally, could be anything. You're changing state all over the place, you're doing stuff all over time. It's got to be fast. If it's less than 30 frames per second, it's, you know, you basically get fired. It needs to be stable. We can't like Erlang the problem. The game can't crash and you spin up a new game and that's all okay. It's like, it needs to be one experience that just like runs stably. And then on top of that, games have this other pressure that a lot of other kinds of code doesn't, is that it has to be subjectively good. It has to be, you know, aesthetically pleasing. It has to be fun, or at least experiential. So you can't, you know, solve a similar problem to what you're trying to solve. Halo would be a lot easier to build if it didn't have vehicles, for example. But you can't just pull vehicles out of Halo because it's just hard to do. So you have to like actually build the experience itself. And a good friend of mine, a brilliant hacker, put it this way. He said, in games, you have to solve every hard problem in computer science 60 times a second. And that's hard enough, but then these are the tools that you're left to do it in. And if you get to code in Lua, that's the ivory tower of video game development, right? It's mostly C++, and C# stuff. So because of how hard it is and the tools that you're left with, video game development is not only hard, it actually sucks. It's just this really painful, like not fun process in general. And a lot of people, the people who do it just sort of learn to live with it and just get on with it, but that's not something that I was able to do. So here we are. We wanted to, so Tim's actually knows Clojure, which this was my first Clojure project, so here I am. I know Unity, so I've been doing Unity for 5 years. So this is Tim's first Unity project. Between the two of us is a very competent engineer. It's kind of... I moved into this studio in Brooklyn where I share space with Tim's and David Nolan, who many of you know, and Kovas, who's also here in the audience. A lot of people who do Clojure programming and was sort of immersed in that world. And it's this really amazing language that does incredible things that could be great for games. None of this stuff you have access to while you're developing a game. You know, just even a dynamic language would be really nice. So all the other stuff that comes with Clojure is great, but then what we're adding to Clojure then is the ability to do really intense graphics and real industry-grade physics simulations. Unity, for those of you who don't know it, is a standard game industry tool that's freely available, but also deploys to the PlayStation 4. So the ceiling to its use is very, very high, if there is a ceiling at all. So Unity development gets a lot from having Clojure integrated with it, but also Clojure developers get a lot from having access to Unity as this amazing thing to build against. So a lot of people react like this when they hear about the project. And we've been asked how it even worked. So the sort of very abbreviated summary of the architecture, or at least the process at which we arrived at the current architecture, is Unity is built on Mono, which is an open source implementation of Microsoft's Common Language Runtime, .NET, C#, VM. There's always been a port of Clojure to the CLR, for those of you who are not familiar. It is heroically maintained by this man, David Miller, who I don't know if he's here, but I owe him not just a drink, but like the deed to a bar, because the work that he's done has made anything that Tim's and I have tried possible. It's really incredible what he's done. And everybody involved in the Clojure CLR project, but his sort of spearheading it has been great. So that was the path to victory that we saw, and we got really excited. We're like, oh, it's just, in 2 moves, we have it. But then the reality is Unity actually ships a really old version of Mono. This is from 2004. So it's missing a lot of really useful features like Microsoft.dynamic, which is what dynamic languages use on the CLR. So we had to bring that in externally. It also has weird hacks that Unity introduced. So they have a fork of Mono that they use. Also, the Clojure CLR implementation is buggy in a lot of places. And Unity is a closed source black box, so we actually have no idea what it's doing most of the time. So our elegant 2-move perfect architecture was kind of muddied. So we, over a few drunken evenings, deleted files, commented lines out, just sort of traced these errors down, and actually brought it down to a few very focused edits to the Clojure CLR codebase, and we got it to run inside of Unity. So this isn't a kind of networked interop thing. This is actually Clojure running inside the Unity editor, and when you export an app, running inside the Unity engine while it's playing. So thanks. But so this is one of my favorites. There's a thing in the version of Mono that we have called reader writer lock slim that was not available, so we just grepped for it and commented it out, and everything worked. So don't use multi-methods or refs, because who knows?
Well, you can use multi-methods. Don't use them with concurrency.
Yeah, that's basically, yeah. There's all the locks are taken off.
Would it be easier to provide your own empty implementation of reader writer lock slim?
Maybe. It's possible to do. So there was another Clojure Unity effort, and they actually re-implemented the behavior of reader writer lock slim to make it work. And they saw what we did, and they're like, "Oh, that would have saved a lot of time." That was okay.
But they might actually have.
Yeah. So this is
multi-methods.
And this is the sort of segue into this is like pre-alpha software. This is still just getting out of the door of, oh, this actually kind of sort of works, right? So there's a lot of hacks like this in place to keep it together. That said, in most cases, it tends to work better than it should. So I'm going to stop doing, I want to stop doing slides soon because I want to just dive into code. Tim's and I have built a few things that someone else has. This is Joseph Parker, who's someone on Twitter who heard about the project and somehow against our daily changes and completely bizarre and buggy code, has been building stuff, this amazing stuff, and just posting screenshots to Twitter. So he's the most proficient Clojure Unity hacker on earth right now. Big shout out and thanks to him. He's really been incredible. These are some screenshots of some of the stuff that he's done, and I have some of his code that I'm going to walk you guys through. So one of the things that's really exciting is the ability to procedurally generate terrain and shapes and geometry. And Unity is really good at representing geometry, and Clojure is really good at processing data. So when you put the two together, you can very tersely just spit all this kind of stuff out. This is a sort of map that he's building for, I think it's a platformer that he's working on. This is another, a more detailed thing. So that's all art that he's done in Blender, which is a 3D modeling program. And he just generates the terrain in Clojure Unity. So you see that there's logic here to only apply moss to the cubes that are on top and not below. So I haven't seen the code behind this, but it's doing something interesting. Here he's just generating a bunch of little roboids. This one didn't load properly, but he made a dungeon generator. So there's a def dungeon in his code base, which is kind of amazing. This is another one of the platformers. Yeah. So this is my favorite. This is like really liney and just beautiful. It's like, if anyone's played the game Mirror's Edge, there are like levels like this that they probably laid out by hand, those poor bastards. So you have like this, right? You know, in one stroke, you're able to just like generate all that. And this is from some code that we have running. He's able to generate these like these tree shapes. So without further...
Well, and again, this is all with no documentation or anything, which might mean that it's possible to read some of the coding.
There you go.
But
yeah.
So
I mean, because it's Clojure, you get interop for free. So he's just using the interop with C#, and he's able to like spit all this stuff out. Anything you want to add before I dive into
That's Wolfram was showing that yesterday.
Yes.
yeah.
Yeah, he was. Yeah, this runs a little bit faster than Mathematica, though, so I'll just say that. So let's see. This is the scary part of the talk, where I write code. So this is Unity. For those of you not familiar with it, I'll walk you through it. It's an editing environment. This is where I can like move things around. I can create cubes. I can move the cubes around. Down here is the game view. This is what, when I export it, my audience will see. So this is the sort of final view. It's controlled by the camera that's in the world. And then this is my like editing behind-the-scenes view. Unity's architecture is based on something called entity component systems, which is very popular in the video games industry. More or less, like traditional linear inheritance has been abandoned. It just doesn't work. So a lot of these software shops, like these game shops, will actually use C++, but not use normal C++ inheritance. They'll use what's called an entity component system. What that means is your objects are these just containers. So Unity calls them game objects, and they're listed here. And when I click on one, you see in the inspector what's inside of it. And it's a list of components. And that's what actually gives the object any kind of behavior. So there's no special camera object in Unity. It's just an empty container with a camera component. So you can add these components to any other objects and mix and match them. It's actually a very, very powerful system. And that's almost the entirety of it, what I just described. It's very sort of small and elegant. And for the most part, Unity has done a good job of keeping it that way. And that makes it very amenable to the stuff that Clojure can do. And Tim's has built an insane library that entirely leverages that allows you to turn Clojure persistent data structures into Unity scene graph objects and vice versa. So we sort of close the loop. But the interesting part, is this. So I'm going to try and squeeze everything in. So, good. Yes. Is that okay? A little more? More? Okay.
Wow, you got the REPL working with Sublime Text? You guys are really...
By some definition of working. Yeah, the Sublime Text REPL is kind of janky, but it's how it, in inferior Lisp and Emacs, how is it?
Yeah.
It's good, right? It keeps up.
Yeah.
No, so this is a REPL into Unity. I can affect the Unity scene graph. And there's my game object. Hello strange loop, right? I can object. Right, so it's entirely, these are just interop calls for those of you who aren't familiar with Clojure. So that's basically Clojure equivalent of the C# syntax that you would use to create and destroy objects. We have, and if we're lucky, nope, that's not a thing.
Yeah.
So we have, we're mostly relying on interop now. We're trying not to be too hasty and like building out some wonky API that you need to learn. So our core is extremely small, and it mostly has nice things like this. There's a cube that I just created from the REPL. That's quite nice. So this gets more interesting when I start. Oh, pretend you didn't see that. This is me confirming that this stuff works. Okay.
I mean, I think they've probably seen it by now.
Well, okay, then in that case. So I will work up to this, but this is where we're headed. The exciting thing.
There you go.
There we go. So let me just confirm that this actually still works. Yes, okay. So we have boxes. So we can quickly destroy things with a cube. So Tim's has built a amazing library that he calls Hydrate. That's going to be part of Unity Core that I'd like you to talk more about. Yeah.
Yeah.
So do you want to talk about it first, or I could demo it, or?
I mean, sure. Yeah, you can demo it. So.
Cool. So, like I said, the Unity scene graph is entirely made up of game objects and the components that inhabit them. Unity is also designed to be entirely serializable, which means that at any moment, it needs to be able to take all the objects in your game and just dump them to a disk. And the way that it does, it needs to be able to reload them from the disk. So the way that it does hot code loading, which Unity is able to do, is it'll dump all the objects in memory to disk, actually pull mono out of memory, load in the new assemblies, put mono back into memory, and then reinstantiate all of your objects from scratch, and then manually, well, I mean not manually, but individually reassign the values of all the publicly mutable fields. So it's a kind of a really heavy-handed approach, but it also means that across the board, Unity's API and Unity's objects are designed to be represented as data. And the hydration and dehydration API is the ability to take Clojure maps and arrays and Clojure maps and vectors, sorry, and persistent data structures and turn them into Unity game objects, and then take Unity game objects and do the reverse.
Yeah, I can just maybe mention how we did that. So the can you hear me first of all? Okay, so we wanted to be able to do this at runtime and very quickly, so without incurring any kind of reflection overhead. So in the Hydrate namespace, we scan the entire core Unity API, every component type that we have access to, which is about 81 types, and then all of the value types, which are an interesting quirk of the CLR. They're like extensible primitives. And we generate custom populator functions, is what we're calling them, which, given a map from keywords to property values of some sort, and the keywords named after a property of one of the Unity components, will just set that component, given a pre-existing component. That's a little tangled. But on top of this, we have a hydration API, which, when you give it a map representation of some Unity game object or component at arbitrary levels of nesting, will instantiate it in the scene graph. And we're trying to do this with as few allocations as possible. In principle, you could do it with almost no allocations, hopefully. It's just a KV reduce across the map, and then you recur into the next map, and so on. And so it's pretty fast.
It's really fast. It's fast enough to do at runtime, which is really exciting. So here you see I'm calling Hydrate. I'm passing it a map that maps name to some object, and then these keys correspond to Unity built-in components. You can, in theory, have any number of components of a particular type, although in practice you normally only have one. So if I take this out, you'll see that so this creates a sum object And you see the position of the transform is 1, 2, and 3. And that's coming from the fact that I gave it a transform, and it's a vector of maps. And the first one has a position of 1, 2, and 3. So what I have in my editor is an entirely persistent representation of what can then be hydrated into an actual Unity object. And if I put back rigid body, I hydrate that. Now there's a rigid body attached to that component. It has a mass of 10. So like Tim said, all of these keys are auto-generated by reflecting on the API at build time. So when you get this, the DLL already has all these populators and hydrators and knows what to do with all of these keys. So you could also set is kinematic and use gravity to true and false, and it knows how to handle all of those. Which means that you can sort of build data as you would in Clojure, and then when you're ready, just throw it at hydrate and it comes to life.
Yeah, all of this is AOT compiled. So yeah. Actually building the hydrate namespace takes about 12 minutes on my computer. Yeah. But you don't have to do that because we're shipping it.
So this gets exciting when you start to do things like, so the part of the hydrate API is populate. Hydrate will create an object from scratch. Populate will give it an existing object, assign values within that object and components. So if I create a cube and then populate it, so this is a cube that was created from scratch. It has a position 1, 2, and 3, and it has a mass of 10 in the rigid body. So this is a fairly common idiom in Unity. You'll create sort of a template object. Unity even has a system in place that's mostly broken called prefabs, where you can save these objects to disk. So you'll create a template object, you'll load it into Unity, and then you'll set certain values and parameters on it, and then you'll set it off. So here we're using their built-in cube primitive, which again is not a special thing. It just saves us the trouble of attaching a mesh renderer component and a box collider and a mesh filter. These are the things that make a cube in Unity. We're taking their built-in prefab essentially for it and just setting the values that we're interested in. So in this case, it's position and its mass. And then now, oh, sorry about that. So like I said, Tim's is the Clojure hacker.
You need it.
So this is under all. Oh, it would help if I didn't type 1, 2, 3. You guys get to watch me learn Clojure. There we go. So, cube. Right. Get more interesting. What if we alternated between cubes and spheres? So if 2.5 cube, otherwise sphere. Does that seem right? It's kind of small.
Yeah. How many parentheses?
Yeah. Yes.
I haven't done any Unity development at all. Is this kind of applied coding possible in any existing Unity framework? I mean, you have to do a rebuild cycle, right? Rerun, or is there other more dynamic?
You know, in order to use Clojure, in order to use what we've built.
Yeah. What do you mean rebuild?
Yeah, without Clojure, I mean, you have to write C# code and go through a build cycle before you can try out new code, or is there something more alive?
I was going to say, is there a REPL for
No,
C#?
yeah, there's no REPL.
There's something like this. It's a C# REPL, we haven't used it very much, but C#.
No, it's yeah, and
Kind
it's not officially supported. So this is alternating between
Yeah.
spheres and cubes. So no, to answer your question, no, there is a build process and a build step. Unity does a fairly good job of managing like hot code swaps. So you can like rewrite your C# component, have it compile at runtime, and then it'll swap out the classes for you. But there's nothing live like this or like this. Oh, interesting. Oh, yeah. No, I mean, yeah. Everything that we're doing is actually someone asked us why we didn't write our own game engine and not just like not deal with Unity's weird stuff.
Unity's very good
Yeah.
system. I don't want.
It's yeah, and what you get by well, and what you get from targeting Unity is well, you get this. I'm sorry, this is my favorite. I mean, you get that, right? Like this is like this is not a joke. Like this is actually like more iOS stuff, but I mean a lot of console stuff gets written in Unity. So the idea of having access to an industry standard, not to knock other engines, but an industry standard tool with a large community is sort of what we're sort of after and hoping for. So you could probably guess where I'm headed with this. So I'm gonna replace this mesh collider. I don't know why it comes with a mesh collider. They're the worst. With a box collider, and make sure that my camera is positioned. Now I need a light, so I'm gonna create a light. Boom. And then this is my light. And then, if we're lucky, run it. Don't you love single-threaded code? There we go. Oh.
Here, can you make it bigger?
Yeah. I'm going to make it bigger for now. So it falls. So when we got this far, we just like did this for like days. Let's like tilt it to make it more interesting. So that's a big part of what we're excited about. It's not the whole thing. There we go. And it's not the whole thing, but having access to a REPL where you can sketch things out live. And I think the reason that it doesn't exist for C#, I mean, there is a C# REPL, but you know, it's one thing to sketch in a dynamic language. It's another thing to sketch in a statically typed language. It's just so much more fluid when you don't have to like worry about all that stuff. And what Clojure gives you is type hints. So once you've figured out what you're doing, you can then post-fact type hint it and generate optimized bytecode. So this is a huge use case that we see for Unity, is just being able to REPL into your scene and generate basically a landscape, a setup. The other part, this is also exciting. So everything that was in the scene right now were just Unity components, right? Colliders, mesh filters, and all that. We've also made it possible to write components from scratch in Clojure. And that means you have Clojure code running at runtime, making behavioral decisions about the objects in the game. So you see here, well, actually, let me run it, and we'll see what that looks like. Woo, colors. So these are all little squiggly guys. Each one of these is attached to one of these components. I'll pause it. So this is the world. So each one of these squiggle objects in the right is associated with one of these color squiggles. And like I said, in Unity, everything is just game objects and components. So the components that are attached to this little guy are a transform, which encodes the position, rotation, and scale in space, a line renderer, which is a built-in component to Unity that knows how to draw sort of trails given a sequence of points, and then a squiggle script, which, when I say works better than it should, this is like a component written in Clojure that not only works, but actually shows up in the GUI, which is so far beyond anything I would have been happy with. But yeah, it like does its best. It's like, yeah, it's a component. It's got some stuff you could set. And then the code to implement this is... So we have a def component. And we had to write a special form for that, which you could
so this is probably the dirtiest hack we did. For another reason, too, we had to fork Clojure CLR because Unity uses this weird, antiquated version of Mono. And the Clojure CLR development has progressed afterwards. So what our policy for the moment is to have our little version of it, forward port it as much as we can, and just sort of try to keep as up to date with the main branch of Clojure Unity as possible, but stop short of like partial implementations of it. We were going to fix the thing with like the multi-methods, but we did hit one problem, which is that Clojure is extremely it doesn't like class-based inheritance at all, and that makes a lot of sense, I think. But the Unity API demands class-based inheritance. And not just class-based inheritance in the sense of you need to extend a Unity class, and then you need to emit the name of that class. So Clojure's proxy, which lets you kind of extend a class anonymously, isn't going to help us. And none of the other type definition forms in Clojure that we could find, or we know all of them, seem to be able to help us either. So very sadly, we had to sneak in a special form, a new special form in Clojure that permits the extension of the game object class in Unity, and then exposes, for GUI reasons, public mutable fields. So this is a very nasty addition to Clojure, and we don't want people to be using it for actual Clojure code, but it seems completely necessary for interop and to have a smooth experience.
Right. So that's what the def component macro expands down into def class, which is our sort of generic.
It's horrible.
It's pretty bad. Yeah. But it's I mean, APIs built on inheritance are, I don't know, what can you say? But yeah, so it's based on def type. The difference is that it has a superclass, right? Which means that the bytecode we generate is actually quite different. And on the CLR, I don't know what it does on the JVM, but on the CLR, def type will actually emit a stub class for type hinting purposes that your subclass that the def type class will then inherit from. We don't have a stub class at all because we just have a superclass. So the bytecode is quite different, but the code is based on def type. So it isn't some completely weird, wonky new thing. It's a hacked def type. But this is what it looks like. You say def component, you say the name of your component, you list out the fields, the publicly mutable fields of this component, and you'll notice size and speed show up in the inspector. So the way Unity works is it'll actually reflect on your class and find the public fields of types that it knows how to render inspectors for, and it'll just do that for you. You can write your own inspectors from scratch, and that's something we haven't fully exposed or figured out yet. But this is the default behavior, and it's quite nice. And then the next thing you have to do is there's a set of 40 or so messages, which massive air quotes around that, because this is something that Unity just made up. They violate C# dispatch all over the place. So you basically implement specially named methods on your class that it then uses reflection to find and cache. And then it calls all the updates in a row and then like all the start methods in a row. And so it's doing something completely bizarre. So the methods just have to have that name, and Unity will find them.
There's no interface or anything.
No, there's no interface. There's none of that, right? Yeah, this is like a dark, dark place. It's what? It's opinionated. Yes, it's opinionated. That's certainly one word to use. So awake, start, these are, you'll notice, if you're familiar with def type, you'll notice that we're not declaring any like, I awake, right? We're not doing that. Or we're not even like unity game, you know. Our macro is sort of taking care of that for you because it'd be a serious performance hit to basically declare the entire Unity message system as a protocol, because the compiler will emit stub methods for every single method, even if it's not there, and Unity will try and call these empty methods, and it gets like super slow. So we basically enumerated all of them and the types that they take, and we have protocols for all of them that we like inject. And this is something you almost never call these methods on your own, so it's not something that the user has to worry about too much, but it produces optimal code. But this is how you do, how do you make it so that when two things bump into each other, something happens? You implement on collision enter. How do you make it so that when something is destroyed, something happens? You implement on destroy. Some of them are on joint break. That's something I've never used. But that's like if you have like two joints and they snap, that's where you can react to it. And the way you do it in Clojure is by implementing these methods, or these functions and these forms. So start basically is called at the very beginning. So for our squiggles, we generate a random color. We use interop to set the line renderer components. We call the set colors method on it. And it actually takes two colors that it fades between. So this is from RGB transparent to RGB solid. And then we set trails, which is also a public field, but it's not type hinted. So it's just an object. It could be anything. Clojure will dynamically figure that out. But this is what, as someone new to Clojure and someone who's been doing Unity for a while, this is what's kind of exciting to me. It's actually, the trail that they follow is a lazy sequence that's being like evaluated over time. And we set that up here. It's basically we generate a random next step from inside unit sphere. Unity will give you a random vector inside of a sphere of radius 1. And we just use this like gross interop syntax to add to the previous point. And that's where you get that like swimming behavior. And then on update, we call our function setLine. We had a catmull rom. Catmull rom is a line smoothing function. It's a spline generation function. You give it an array, basically a vector of points, and it gives you a new vector of more points that represent a sort of smoothed path through all those points. And this is what setLine looks like. It's kind of what you would expect it to be. The line renderer set position API requires the individual position of each point to be set. And then that's it. And then this Clojure code actually runs at runtime. So in addition to being able to use the REPL and the sort of liveness to set things up, you can actually write Clojure code and use Clojure data structures and functionality at runtime, which is super exciting.
Yeah, we didn't know if it was going to be fast enough or if the garbage collection pressure was going to be too high, but yeah. It isn't.
Yeah.
So.
Yes.
Can you go back to the code for
Certainly, yeah.
So I'm looking, we're setting the trails. Could you scroll?
Mm-hmm.
Oh, okay, so that's from your start. So you're going to do that after you're rehydrated at runtime.
Yep. Yep. Yes.
I haven't done any game programming, but as an outsider, it seems a bit too stateful. So how does this store state? Like, does every component has its own state, and is there a global state?
In Unity, so the question was how does Unity store state effectively? That's what Unity uses. It's the public mutable fields.
Yeah. So there's a global scene graph.
Yeah.
Right.
Yeah.
And that's expected to contain your data in publicly mutable fields scattered throughout these components. The components are then accessible via and exist only in reference to their containing game object, which is really just a UID.
Yeah.
So.
Yeah. So you have this. Yeah. Exactly. Go ahead.
I noticed in your awake statements you've got requiring of namespaces. Can you explain why you have to do that?
What are you talking about? So yeah, there's the main source of bugs at the moment is sort of learning the Clojure compilation machinery, which is just us figuring out learning Clojure at a much lower level, but then also dealing with the black box of Unity. We have problems where at runtime a class will not, like the namespace that a class was defined in will not actually be loaded.
Well, yeah, I mean, it's not a bug. That's just Clojure. The type doesn't is very different from the namespace, right? So to trigger the static initializers of the namespace, you have to have that require statement somewhere. But you can still reference the type, right? So and so if you have a game scene which has saved all of these Clojure-defined types, when they load up, they're not going to know what their methods mean.
Yeah. But this is the kind of thing that, so we've talked a lot about what our API should even be, and we don't want it to be, I mean, Unity is a big enough beast on its own, so our strategy is to make as small a core as possible to make working in Unity pleasant. This is the kind of stuff that could be macroed away, right? Yes?
So I've been vaguely following, like, Unity 5 is coming out, and that's going to rev the version of Mono, I think.
Yes. Oh my God. So excited. I've been waiting for 4 years, even before this project. Yeah. It'll probably break everything we've done, but it'll be for the better. Yeah. Yeah.
I mean, we'll see.
Yeah, we'll see. They're also talking about IL2 CPP, which I don't know if anybody's following Unity compiler news, but they're talking about making their own machinery that translates .NET IL into C++ and then compiles that, which is kind of terrifying. So yeah, that's going to be an interesting thing to program against. But yeah, the new version of Mono is very exciting. It's only good news as far as I'm concerned.
Maybe we should keep.
Yeah.
Would you switch to the normal Clojure CLR?
I mean, yeah, ideally we would like to run a stock CLR, Clojure CLR implementation. It's going to be hard because of, like Tim said, we need named classes and we need inheritance. So we may always have that special form in one form or another. But yeah, ideally we wouldn't have commented out a multi-threading code. So I think we're about at time. We could.
I mean, so some things people have been interested in are how crazy you can get with persistent data structures in this.
Right.
Pretty crazy is the idea. Unfortunately, I tried to get too ambitious with my Minecraft port, so I don't have that to show you right now, but there'll be a screencast soon. Yeah. So you have components.
So yeah, we could summarize. We have components, the REPL, interop, and hydration API are all things that we're comfortable with that are working quite well. We can also export on desktop, so you can actually have just a .app that you just run and share around. What we do not have yet is a name. Please don't sue us. We haven't wrapped all the Unity API. We're being very sort of conservative in that regard. The integration with Unity's GUI is good in places and bad in others, so it's getting there. None of this is documented. You just saw all the examples. But that kind of stuff is just it's not there yet. We also, in terms of, there are just things we just don't know yet. Like sometimes Unity just won't see your class even though you've defined it, and we just don't really have answers yet. And that's just something that takes more time and just like more
you can reload it,
plugging away. Yeah, I mean that's what you need to. But like the next steps and what we want to do at the end of this is like get you guys excited about why we're sort of headed in this direction. The things that you can do with persistent data structures in like interactive like game environments, snapshotting. There have been so many times in my work when I've just needed to dump the entire state to debug or just to know what was happening, or record the state in a certain bracketed time. And you can build a system like that, but using dehydration, it just happens, right? You just dehydrate the scene graph and it's done. It's a solved
that's
problem.
the inverse of hydration. It's idempotent. So it's idempotent with populate, which is the mutating form of hydration. So if you hydrate something, so if you populate something, dehydrate it, and populate it, hydrate it again, depopulate it. If you hydrate a spec and then you dehydrate that,
It should be the same as the original spec?
Right.
Right,
Yeah.
Basically. It's basically a closed. Logic-driven game design, so using core logic, you can basically generate the set of all levels that match certain constraints, which for testing is super, super exciting. Maybe there's like some part of your game or your experience that doesn't make a whole lot of sense and you want to tweak it, so you just give the game to a bunch of people, and you have each one sort of generate a level from that set that matches the constraints. So I want a platformer where the enemy is here, and you meet the boss at 30 seconds before this happens, and some kind of set of constraints, and it generates all those for you. These are pie-in-the-sky dreams, of course. Procedural meshes, we have someone in New York who's super excited about building a procedural mesh API to generate geometry from scratch. Unity has an API for this, but it's assign values to an array, and that's the API. So there's a lot more that could be done with that. Speculative AI is something that I'm really excited about. AI where you can cheaply clone the entire world and like run micro experiments in separate threads on the world and then pick courses of action that you then commit in the main thread. Like these are things you couldn't even really talk about in like normal C#. This is the amount of effort that would go into just doing half of what I said makes it not even worth exploring. But with persistent data structures, and Unity already has agents and all that, this stuff becomes things that you can think about. So that's the stuff that we're excited about, and we hope that you guys pick it up and mess around with it.